Hi, Anthony. I'm going to give maybe an extra minute or two today on the do now, just because I know you guys have to take a picture and submit your work and stuff. But yeah, I would like everyone to get started on that. Marche, it says that you aren't able to open the do now. Is that a problem that anyone else is having? Or I think if you just click on the do now.png, it should just open an image. So you don't have to download it or anything, but it should just pop up on your screen. So if other people are getting that issue, just let me know. But I think it should work. Okay, if you're having trouble with it, just don't worry about it for now. See if you can. Okay, Marche, give me 1 second. I'm gonna actually take a look. Sorry, give me 1 sec. Okay, that's fine. If you're able to, can you look at it on your computer instead and see if that works? Hi Jenny, hi OTCA. For everyone who's just joining now, just have your sound muted, video on, and log on to Google Classroom and start the do now. The do now should take 4 minutes or so starting from now, I'd say, just because I'm asking you guys to submit a picture. And it might be a bit challenging. Oh, okay, Marche. That's fine, just don't worry about it for now, I guess. If other people are having an issue where they can't see the do now though, please let me know. Hi, Naima. Cool. So yeah, so everyone who's just coming in, just get started on the do now, and then have your video on and sound off. And then I see a couple people who've answered the morning wake up question. And today the question is, do you have anything on your bucket list? Okay, that is a typo right there. On your bucket list specifically, and have you ever completed anything on that list? So Emily said that one thing on her bucket list is to get 2 doctorate degrees. That is actually, that's a very cool goal, but that is extremely, extremely time consuming. So I hope you're able to accomplish that. That's very cool. I don't know if you can do 2 like PhDs at the same time, but usually they take like at least 6 years each. So if you can do it at the same time, then definitely do that. Otherwise, that's like 12 years of school at a minimum. And we are going to go over the do now later today. So like right after this. So just do your best work on it. If you don't remember or you don't know how to like algebraically manipulate some of the problems, then just try your best. And we said one in nursing and one in computer science. Wow. That's a very interesting combination. I wonder what you can actually like do with that. Actually, also, I realized I can just show the problems on the screen. So if anyone isn't able to see the do now, you can just look at the problems on the screen and then submit what you can. Again, more so, I just want you guys to be working and like thinking about these type of problems because we're going to do power rule today. And power rule is pretty easy. It's just that it's harder when we deal with like weird polynomials with like square roots and like negative exponents and stuff like that. So Jay, you said you want to go to Japan and you want to skydive. Awesome. I don't know if I want to skydive, but I would really like to go to Japan. So Vor, you said one of the things on yours is to be the first person to touch the sun. Okay. Okay. I'm pretty sure. I don't even know if like we would ever get to the point where we could get like that close to the sun without dying, of course. But yeah, I think you've had like 3 very interesting answers 3 days in a row. I don't remember what you said yesterday. I just remember you said you wanted to be a hitman as a career of choice, which is very amusing. Okay, I'm gonna give like 2 more minutes on the do now because I don't have that many submissions right now, and I understand it's probably kind of difficult, some of the problems. So if you're stuck on one of them, just submit what you have, or stuck on more than one of them, that's totally fine. We're gonna go through how to manipulate these so that we can use power rule. And thank you to everyone who has their cameras on. I really appreciate it. If you aren't able to have your camera on, and again, you're not on the list, just try to message me. Just want to have as many students on with their cameras on as possible. Right. Thanks, Kalia. Right. Thanks for letting me know, Anthony. Are people having trouble like submitting pictures on the do now, or are people just like working through it? Can I get a couple people in chat just letting me know where they're at with the do now? If you're still working on it, would you be able to just like raise your hand on Zoom or something like that? All right, thanks for letting me know, Favor. Thanks, Moshe. Okay. Okay, that's totally fine. I'm gonna start working on the do now for right now. And we're gonna go through each of the problems. So if you're struggling, it's totally fine. There's a few rules that we can remember, and it'll help us immensely on the do now. So can I get some volunteers for the first problem? If you're able to rewrite each of these functions below into the form of a to the xn power. So how would you do that for 10 square root of x? Can I get some volunteers in chat, or I'm going to cold call? Awesome. Emily, can I get your thoughts on the first problem? Emily, are you able to unmute, or?
I said you could, I rewrite it as 10x squared.
Gotcha. So you wrote it as 10x squared. Janice, could you come off mute and just quickly say whether you agree or disagree, and maybe why you say that?
I would sort of disagree because it's the square root of x. I would kind of say it would be like 10x of 1/2.
Gotcha. Okay. Yeah, so 10x to the 1/2 is the right answer. But how did you get to this answer, or is this something you just kind of memorized?
Because if it's square root, like the 2 on the outside is invisible. So yeah, I kind of memorized it.
Awesome. Yeah, so this is going to be the first rule that we kind of work with today, which is for square roots. So it's going to be called the fractional exponent rule. And I would like for everyone to have this in their notes, because there's going to be 2 rules in addition to power rule, which I think many of you guys are kind of familiar with, or pretty familiar with. But these 2 rules will help us like simplify these weird like terms so that we can use power rule. But the fractional exponent rule says that if a value is like this, so a to the n power, that's equivalent to so a to the m over n, it's equivalent to this form in like radical form, or I could just rewrite this like this. They're the same idea. So essentially what you see here is that the denominator and the root that you're taking, like this, in this case it'd be the square root, are the same. And then you take the actual term inside the radical, inside this radical, and then you bring it to the power of the numerator, if that makes sense. So if I were to rewrite 10 square root of x, right? So I have 10, and then as Shanice said, the 2 is invisible, right? And then, so if the 2 is invisible, and then this really means x to the first power, for example, if I switch it to, sorry, I'm gonna just rewrite this really quick. If I go from this form to this form, I can rewrite it, right? So it'd be x to the 1, right? Because the m is 1 in this case. You notice it says a to the m here, so x to the 1 here. So 1 goes into the numerator. So 1 goes into the numerator over n. In this case, n is the square root. It's the 2, which is invisible in our original problem. So it'd be x to the 1/2. So given that, I would like people to try problem 3 now and just do this part. So how would I switch this radical into a fractional form? So I'm going to give everyone 30 seconds to a minute. Again, we're going from this form into this form. So this form into the same form. So we're going to write this as a fractional exponent. And once you get your answer, please send your name in the chat. Awesome. Albert, Marche, great job. Thanks, Kalia. Thanks, Taver. Yeah, awesome. You guys are definitely getting it. A quick, just way that I start to remember it is that whatever this number is, the smaller, radical number, that goes in the denominator. So, and then the exponent, that goes in the numerator. So, Albert, can I get you to come off of mute and share what you put as your answer?
I put x to 2/5 power.
Gotcha. Yep, that's exactly right. So x to the 2/5. So why did you decide to put the 2 on the top and the 5 on the bottom?
Because in the fractional exponent rule, the number that's inside of the square root thing, it's labeled as m, and then when it switches to just a regular fraction as an exponent, the m is on top.
Awesome. Exactly right. And then how about the 5?
And the 5 is labeled as an n. I mean, the number outside of the square root thing is n, and then in the exponent, the fragment, the fraction that has an exponent, it's labeled as it's basically going to be an n. So the 5 would be in the denominator.
Yeah, awesome. Okay, thanks for clarifying that. Yeah, so basically you follow this exact rule, and you just looked at the matching components, right? So the 2 is the m, so then you moved the 2 to the numerator here, right? And then the 5 is the n, right? The 5 is the n, so then you move the 5 to the n term there. So yeah, essentially you're able to switch between radicals and fractional exponents. And that's really useful, right? Because when we have a fractional exponent, it's much easier to do power rule with this than, say, a term that looks like this. And then just really quick to re-emphasize this point, you would take the denominator, so 5, that goes into the root. So in this case, we're taking the 5th root of the problem. And then the numerator is what you're taking, what's inside the radical, that exponent. So the power, in this case, it's to the power of 2. So it'd be x squared. That goes in the numerator. So whatever number's here goes in the denominator. This number goes in the numerator. Awesome. Okay, so I'm going to call really quick on someone for how they would change this 1 over x squared into a power rule form, basically. So a to the xn. Favor, would you be able to come off of mute and share your answer for this?
Oh, okay, here we go. So basically I just brought it up, and since it was in the numerator and I was bringing it up, I knew it would become negative. So I was like, so the 1 is technically invisible. since it would still be the same if it's 1x negative to the negative second power. So I just put I brought it up and then it became 1x negative 1x to the negative second power. Yeah.
Awesome.
Okay.
Yeah. So one x to the negative second power. So basically you had x to the negative second power. So this is going to be the second rule that we emphasized today, which is the negative exponent rule. So I'd also like everyone to write this down. This one I think is easier to remember, personally. But it's essentially saying if I have, let's say, a number or any value to a negative exponent, such as negative n, that's equivalent to 1 over the same thing, but to the positive power. Alternatively, if it's negative in the bottom, right, I can bring it up and turn it positive. So I think instead of like memorizing these two, I think it's easier to just understand it by thinking like anytime you quote unquote like flip, and I'm not sure, this isn't like a precise mathematical language, but you flip an exponent in a fraction, you switch its sign. So you notice here, right, I have negative n, and then I flipped it into the denominator, right? So originally it's in the numerator because I can write it like this, right, just to be more precise, right? It's in the numerator, it's over 1, and then I can bring it to the denominator, and then I just switch the sign of the exponent, so it goes from negative n to n. The same thing applies here. I have b to the negative n, and then I just switch it over the fraction from the denominator to the numerator, and then it turns into b to the n. Tavera asked the question of what would happen to the 4x. So in this case, actually, 4x, we have to rewrite it in this form, right? And if you notice, 4x is kind of already in that form, a to the xn. If you want to be more precise, you can say it's 4x to the first power, just so you get that n term, right? So 1 is the n term. But basically 4x is already in the form that we want for power rule. And I'm sure you guys could probably apply power rule to this pretty easily. The derivative of this is just 4, right? You guys probably know that. So yeah. Again, in this case, the x squared is in the denominator, right? So then we flip it, we bring it up. So now it's x to the negative 2. So I would like everyone to attempt just this term right here, 1 over square root of x. So this is going to combine both rules, and I just want to see if people are able to convert 1 over square root of x using both of these rules into like power rule form. So I'm going to give everyone 1 minute or so to work on this. So first, you're going to have to apply one of the rules and then apply another one of the rules. Awesome. Thank you, Kalia. Great job. Awesome to there. So for everyone working on it, I would say first when we look at this, right, it's hard to apply negative exponent rule, right? Because we don't have an exponent yet, right? It's 1 over square root of x. There's no clear like exponent. So it would be easiest to first apply fractional exponent rule and then see if we can apply negative exponent rule. Also remember that I can rewrite 1 over square root of x just to make it more obvious. It'd be 1 over that, right? Because that's what a square root is. We're taking the second root, and it's 2x to the first power. I'm going to give like 30 more seconds or so, and then call on a few volunteers for this problem. Thanks, Albert. Awesome. Thank you, Emily. Okay, can I first get Jamal? Would you be able to come off of mute and share what you did for this problem?
Still doing it. Like,
Okay, that's fine. I'll give everyone 30 more seconds. All right, Jamal, do you have just like, can you take us in the direction that you started working in?
oh, I got 1x over 1/2. Wait, no, 1x, yeah, to the 1/2 power. That's it.
Got it, 1x to the 1/2 power?
Mhm.
Okay, awesome. How about Emily? Could you come off of mute and say whether you agree or disagree and kind of take us through how you did it?
Oh, I said negative x to 1/2 power.
negative x to the 1/2 power. Gotcha. So what was your first step?
I first turned it into, I put like 2 over in the denominator. So I know it's gonna be 1/2 for the exponent. And it's negative because it's saying minus 1 over the square root of x.
Awesome. Okay, thank you. Okay, so the first thing you did was you said you put it to the 1/2 power in the denominator. So that's applying fractional exponent rule. Right? So again, we just put the 2 in the denominator, right? So the 2 is the n here, right? And then you put that in the denominator. So it would be 1 over x. We're keeping x in the denominator too, right? Because it's also the whole term is in the denominator. So it'd be over 2, and then the 1, right? The 1 here, that corresponds to the m here. So the m is going to go in the numerator. So we're going to get 1/2. And Tavera, would you be able to come off mute and just take us to the final step on what you did after this, after you got to this step?
So to put it into the form that we wanted, you have to bring x to 1/2 power up, and then it's gonna become negative since it's in the denominator.
Yep, that's exactly right. So all we're going to do now is we're going to flip it up to the numerator, right? And then every time you flip it, you just switch the sign of the exponent. So instead of x to the 1/2 being positive in the denominator, now it's going to be in the numerator, and it's going to be x to the negative 1/2. And then it's in the numerator because I could write it like this, right? So it's in the numerator. But yeah, when I bring it up, basically, I just switch the sign. So now it's x to the negative 1/2. And that is using negative exponent rule. So I would definitely like everyone to have this example for sure written down in their notes, because this kind of illustrates very clearly both of the rules, right? So I can take a square root, change the square root into a fractional exponent, right? Into a fractional exponent, and then change a fractional exponent that's in the denominator. I can just bring it up to the numerator, and then now it's a negative exponent. Naima, did you have a question?
Yes. Okay, so you flipped it up. I know why it's negative, but you flipped it up because of the negative exponent rule. Like whenever it's a fraction, you just flip it.
Sorry, could you state your question again? So yeah, you do flip it up. What part are you confused about?
Why you put the 1/2? Why did you flip it up to the numerator?
Gotcha. So are you asking why we want it to be negative? Like, why shouldn't we leave it as positive?
No, just why did you flip it?
Okay, so we flipped it because we want to get it into this form, right? We want to have it as a to the xn, because that's easiest for us to apply power rule, right? So like any term where it's like 3x squared, like x to the 1/2, where it's just like some number x to an exponent. That's easiest for us to apply power rule, which we're going to look at in a second. In this case, right, this is not very easy for us to apply power rule, right? Like it just looks confusing. I wouldn't know where to start. But then I can flip this above to the numerator. And then once I do that, I just turn the exponent negative because that's what the rule is. Hopefully that makes sense. So instead of this whole term, right, x to the 1/2, I can bring it up to the numerator and then now all that happens is instead of x to the 1/2, I change it to x to the negative 1/2. So that's essentially negative exponent rule. Hopefully that makes sense. Again, I'm going to give everyone like 10 more seconds just to write this example down. So again, the only reason that we're doing all these rules is just because it's easiest for us to do power rule. Like in the world of math, like it's fine to have something written down as 1/√x. It's just that if we want to practice to apply power rule, we can like switch it with algebra to all these different forms, and then it's easier for us. Okay, so next point, the question simply is, why, if we are trying to find the derivative of a function, why is it useful to have it in a to the xn form? And again, that's power rule. And just to really quickly reiterate power rule, I think most of you guys are pretty familiar with it, but the idea is that if you're finding the derivative now, right? Now we're doing more than just like algebraic manipulation. We're trying to find the derivative. So if we're trying to find the derivative of x to the n, we bring the n down, right? We multiply it by whatever's in front of x. In this case, there's nothing in front of x, so it's just going to be nx, right? So we bring it down, and then we subtract 1 from n. So then it's going to be nx to the n minus 1. So I would like for everyone to have this general form here written down in their notebooks. And d to the dx, this might look kind of confusing. All that means is we're taking the derivative of x to the n. Thanks for letting me know, Ashanti. No worries. So yeah, please have this general form written down. Again, remember, we just take the exponent, bring it down here, multiply it by whatever's in front of x. So that's the n term here. And then we just subtract 1. So I'm going to give just 15 more seconds or so we could get some really quick power rule practice. And I'd like for people to try to just work through these next few problems as quickly as possible. We're just going to do the first one right now. So finding the derivative, we're now trying to find h prime of x, right? So the derivative of 2x cubed. Can I get some answers in chat for what this would be when you apply power rule? Awesome, thank you, Kalia. Awesome, Emily, great job. Awesome, yeah, it's great. I'm gonna cold call really quick. Courtney, would you be able to come off of mute and just say if you did power rule for 2x cubed, what you would get for your answer? Courtney? Courtney, are you there right now? Okay, that's fine. All right, thanks for letting me know about your mic. How about Ruchal?
I got 6x squared.
Gotcha. And then can you just take us really quickly how you got 6x squared? Like what are the 2 steps that you did?
Okay, I moved the exponent in front of the 2 and the exponent in front of the 2, and I multiplied that and got 6x, and then 3 times 2 x, and then because you have to subtract 1, you have to put x 3 minus 1, and you get 6x plus squared. And when you multiply all that together.
Yep, exactly right. So you brought the exponent down, right? You brought the 3 down, and you multiplied it by 2. So that's how we have 3 times 2 here. And then that's going to be 6. And then from 3, you subtracted 1. So that's going to be 6x squared. Awesome. Great job, everyone. Really quickly now, we're going to try to combine some of what we learned before into, so we're going to transition what we learned before with negative exponent rule and fractional exponent rule, right? And then use power rule on that. So for this first problem, I would like people to write down two things. So I would like them to write it down in power rule form. So this is before we actually take the derivative, right? Power rule form, change this into power rule form because it's not currently in power rule form. It's not easy for us to take power rule, to use power rule on this, right? Because it's like confusing. And then I would also like people to find the derivative. So I'm gonna give everyone 1 minute, maybe a bit more than 1 minute for this problem, and then I will call on a few volunteers. Awesome, thanks, Tavir. That is currently, yeah, you have that in power rule form, and then your next step would just be to take the derivative of that using power rule. Awesome, thanks, Kalia. Thank you, Emily. Awesome. Tavir, could I get you to come off mute? And just for this first step, how did you put it in power rule form?
Since it's 1 over 2x to the fourth, I brought up the 2x to the fourth, but you can't. I put 1/2 x to the negative fourth since you brought up the x to the fourth power.
Gotcha. Yeah, so the first step is simply, so we have it originally like this, right? 1 to the 2x to the fourth. All we're going to do is bring the x to the fourth to the numerator. I think one common mistake that people make is to also bring the 2 to the numerator, but we're not going to do that. We're only paying attention to the exponent. So in this case, it's going to be now x to the negative 4, right? Because we bring the x to the fourth, we're flipping it up to the top, and so we switch the signs. But the 2 is going to remain in the denominator, right? So this is still kind of confusing because it's like not really in power rule form. So I'm just going to really quickly rewrite it as 1/2 x to the negative fourth, right? Because that's what we're doing. We're dividing it by 2. It's basically 1/2 times x to the negative fourth. Now we have an actual power rule form where we can simply find the derivative. So Kalia, once we get to this step, we'll actually
X to the negative 1.
Awesome. Yeah, that's exactly right. So I'm just going to show that really quick. Sorry, it says my internet connection is unstable. So you're taking negative 4, you need to multiply it by 1/2, and then the exponent is going to be negative 4, and then you're going to subtract 1, right? Because that's, you also have to subtract 1 from the exponent. So then you're going to get negative 4 over 2, right? Negative 4 times 1/2 is negative 4 over 2, and x to the negative 5th. And that's equal to negative 2 x to the negative 5th. So this is going to be our derivative of our original problem. So I'm going to just walk us through, not this problem, I'm going to walk us through this problem really quick just for the sake of time. And then I'm going to really quickly cover what's going on with the exit ticket today. So please stay for that. So first, we're going to use the rule that's most obvious here, right? We're going to use fractional exponent rule because we have this in like a square root form, but that's kind of confusing, right? So we're going to take x, and then this number, right, the root number, I'm actually not sure exactly what you call that, but it's like when you take the square root, that's the 2, or if you take a cube root, that's the 3, right, that number always goes in the denominator. So it's going to be in the denominator, right? Then the actual exponent, x squared, right, the actual exponent, you're going to put that in the numerator, right? So you're going to change it to x to the 2/5. So that's fractional exponent rule. Now we have this in power rule format. So now if I actually apply power rule, I'm going to multiply 2/5 by 1, right? Because that's the number that's in front of x. I'm actually just going to write it as 2/5 x, right? I just kind of bring it down. I don't really have to multiply it by anything, but I can also say I multiply it by 1 technically. And then I subtract 1 from 2/5. And you got to be careful with your math here. If you subtract 1 from 2/5, right, you're actually doing 2/5 minus 5/5, and that's equal to -3/5. So it's going to be 2/5 to the -3/5 power. So that's going to be your answer. Awesome. Yep, Tavera, great job. And then, like, if you want to be really, like, you can use the skills you learned to adjust this. However, you can bring that exponent down. So now it's instead of 2/5 x to the -3/5 power, you can bring it down. So it's 2/5 x to the 3/5 power, right? Because we just flipped the x from the numerator. Because when you multiply it, it's in the numerator, right? And then you flipped it to the denominator. But that's kind of just an extra point there. Okay, so I'd like everyone to have this written down. Now about the exit ticket. So I hope everyone read through the email that they got about the homework packets yesterday. But the exit ticket today is a bit more in-depth. It's still going to be due at the same time, but I'm going to start grading it for correctness. So I'm going to release a video after class at some point, like working through the exit ticket. So you can like watch it and see how each problem is done. So you get like 100% on the exit ticket. If you don't want to put it in the time to do that, you just want to submit it, that's fine also. But basically I won't be assigning homework packets from now on. It's just going to be that every day each exit ticket is a bit more in-depth, and I'm also going to grade them for correctness. But again, I'm going to put in the same effort in terms of showing people how to do the problems. So I'm also going to release a video, again, every day working through the exit ticket. So definitely look out for that. For everyone, that's going to be the end of class today. So make sure you just turn in your notes and then work on the exit ticket. If you want to wait, the video, again, is going to come out later in the day. I won't be able to release it like right after class, but it's going to come out later in the day. So thanks for that, and I'll see everyone tomorrow.
Oh,
Bye, Kayla. Thanks, Moshe. Yeah, what's up?
Can you go back up to like number 1, the easy practice, real quick?
Oh, easy, yeah.
Yeah, I just gotta get that one down real fast.
Gotcha.